This idea of locus or locus, or however you say this word. Okay. Now, all a locus, like I'm not sure. I want to say locus because you say focus, but then I hear people say locus. But anyway, all it is collection of points that are determined by some stated law. So in fact, we've been dealing with them for ages, because any graph on our number plane is determined by some stated law. The y value is equal to the x value squared, or y value equals x value cubed, and so on. So they are all Locus questions. I suppose there's two ways we can describe the curve though. What we're used to doing is describing it with an equation. But the other way you can do it is just geometrically describe it. So that, the curve is always 2 units away from this point, or something like that. So that's what we're going to have a look at here. So the locus, whatever the word is, of the point, which is always 4 units from the origin. So they're giving us a geometric description. They want us to come up with the equation of the actual curve. All right, something that's always 4 units away from another point, in this case being the origin. Now, sometimes we can just look at these and think about it logically and go, that's got to be this. If you've got something that moves so it's always the same distance from another point, what shape must I get? Yeah, so I know this is going to be a circle. What's its radius going to be? 4. Right? Okay, because we're always 4 units. So yeah, the circumference is always 4 units from the centre, and therefore the centre is the origin. So what's the equation of a circle? Centre, origin, radius 4, x squared plus y squared is 16. So we could think about it logically. If we're unsure, this is where coordinate geometry comes in handy. So locus of a point. Okay, there's one point that's 4 away from the origin. There's another one. There's another one. There's another one. And another one. And another one. Oh, look, there's another one. Oh, and another. And another. Oh, look, another one. And of course, depending on how much time you got on your hands, you start getting a feel. Oh, look, I think I know what this shape is turning out to be. Sure enough, there it is, our circle. Okay. But just say I didn't have that amount of time on my hands. I'd just plot one random point and I'll give it the coordinates x, y. And I'll use my coordinate geometry. What do I know about x, y? It's always 4 units away from the origin. So I could say, the distance from this random point, x, y, to the origin, 0, 0. So using my distance formula, square root of x minus 0 squared plus y minus 0 squared, I know that should equal 4. Square both sides, and then there's my answer. X squared plus y squared is 16. So if I didn't see it by using logic and playing around with the points, I can always go back to coordinate geometry and get the answer. Okay, a point moves so it's always 5 units away, this time not from a point, but a line, that line being the y-axis. So the point's restricted, so it's always 5 units away from the y-axis. What are we going to get? What sort of shape, first of all? So this time, instead of moving consistently from a point, here's a line, and I'm always 5 units away from the line. I'm going to get another line. So what would the equation of this line be? There's random point. What do I know about random point? I know it's 5 units away from the y-axis. Now, that would be a perpendicular distance. So the point that it would meet at the y-axis would be 0y. Let's use our distance formula and see what happens. Square root of x minus 0 squared plus y minus y squared is equal to 5. X squared is 25. There's actually 2 lines, because I never said 5 units on the right-hand side or 5 units on the left-hand side. So it could be either x equals 5, or it could be on the left-hand side, x equals negative 5. A point moves so it's always 3 units away from the line y equals x plus 1. Now there's a very tempting answer to say here. Like if you were just to look at that, what do you think the logical, and by the way it turns out to be incorrect, the logical incorrect answer would be? Anyone want to take a guess at the logical incorrect answer? Yeah, I mean you'd think, oh well it's 3 away, x plus, add 3 on, I get y equals x plus 4. Turns out no, it's not that. So let's have a look at why that happens. There's y equals x plus 1. And the reason I can't just add 3 to it, because if I was to add 3 to it, I would move the curve up 3 units. But when we talk about a distance from a point to a line, it's a perpendicular distance is 3. So it's not that the vertical distance between the lines is 3, it's the perpendicular distance. So there's random point. That's the distance that would equal 3. So I've got to use my perpendicular distance formula. So absolute value of x minus y plus 1 over square root of 1 squared plus minus 1 squared, that will end up being 3. So I've got this absolute value equation to solve. X minus y plus 1 is 3 root 2. So either x minus y plus 1 is equal to 3 root 2, or the negative of x minus y plus 1 is equal to 3 root 2. And so there's our equation. We didn't add 3 to the line, we actually added and subtracted 3 root 2 to the line. Not immediately obvious from the question. In this case, I think we needed to use our coordinate geometry to get that one out. A point moves so that its distance from the x-axis is always 5 times its distance from the y-axis. Now there's 2, I guess, logical answers here. One would probably be right, one would probably be wrong. But one distance is 5 times the other. So to me, logically, it'd either be x is 5 times y or y is 5 times x. Which one is it going to be? So let's draw up a picture. There's random points. Distance to the x-axis, so it would land at the point x0. And distance to the y-axis, so that'll be 0, y. I'm saying that the distance down is 5 times the distance across. So I've just called that d for distance, because obviously I don't know what the distance is. So that one's d, that one's 5d. So in other words, that horizontal distance, that vertical distance is the one I did first, is 5 times the horizontal distance, because I called the horizontal distance d. So x minus x all squared plus y minus 0 all squared is 5 times x minus 0 all squared plus, let's tidy that up, square both sides, so that becomes 25. Y squared is 25x squared, so we get plus or minus 5x. Again, there'd be 2 lines, because who said it had to be the line with the positive slope? There'd be another one going with a negative slope going in the other direction. A point moves so that its distance from one point, 1, 2, is the same as its distance from another point, 5, negative 4. What sort of shape am I going to end up with? So I've got to move so that my distance from these 2 points is always the same. What is it? Be brave, say it loud. It's definitely a line. What's special about the line? Anyone know? It will turn out to be the perpendicular bisector. Right? Let me draw a picture, show you. So there's my 2 points, 1, 2, 5 minus 4. The midpoint must be on this new line, because we're saying the distance from one point to the other will always be there. So I know the midpoint's on that line. And there's our perpendicular bisector. Now, how do I know? Well, I could use congruent triangles, I suppose, to prove it. So, all right, I know it's the perpendicular bisector. So that gives me a way of finding the equation. So if I know it's the perpendicular bisector, I can find the slope of the line joining the 2 points. It's minus 3 on 2. So therefore the slope I want is 2/3, because it's perpendicular to that. I also know it goes through the midpoint, so if I find the midpoint, 3, -1. And then it's just point slope formula. There's my answer. So anytime you've got a point moving so that its distance to two different points are equal, we're going to have the perpendicular bisector of those 2 points. Another way I could have thought about that question. Again, if I did not know that, I could go back to coordinate geometry again and say, well, let's use the distance formula. My random point, xy, its distance to the point 1, 2 is the same as its distance to 5, -4. So those two distances must be equal. Square both sides, expand out. There's a bit of collecting terms there. X squared cancels with x squared, y squared with y squared. And we get 8x minus 12y, not the same. Hang on. I can divide everything by 4. Divide everything by 4, I've got the same line. That might even be a quicker way of doing it, using the distance formula. But 2 different ways of thinking about that question. Ooh. Jeez. We've got questions falling from the sky.